Simplify this rational expression where the numerator is x to the 2n plus x to the n minus 2, and the denominator is x to the 2n minus 1. Now this looks a little bit intimidating at first, but let's see if we can't simplify it. So I want to rewrite this as x to the n squared, which I can do, right? Since once we distribute the squared back in, the exponents multiply, so it's just going to be x to the 2n. So I haven't changed anything. And then x to the n minus 2 will stay the same. And then I want to do the same thing for the x to the 2n in the denominator. So x to the n squared, and I'm going to say that this is 1 squared, because essentially 1 squared is just 1, right? So again, not changing anything. So now notice that this looks like a trinomial where the variable, instead of just x, it's actually x to the n. So let's try to do a substitution. Let x to the n be y. So we're just substituting x to the n for y, basically just replacing. So now our new equation, replacing all the xn's with y's, it's going to look like xn squared, so y squared, plus x to the n, which is just y, minus 2. And then in the denominator, we get x to the n squared, so y squared minus 1 squared. And so now this looks like something a little bit more manageable, right? This looks like the regular trinomials in one variable that we're used to. So now we can factor. So y squared plus y minus 2 factors into y plus 2 times y minus 1, right? Because 2 times negative 1 is negative 2, and 2 plus 1 is positive 1. And then the denominator looks like difference of squares, right? A squared minus b squared, which is equal to a plus b times a minus b. In this case, a is y and b is 1. So we want a plus b, so y plus 1, times a minus b, which is y minus 1. And now there's a y plus minus 1 in the numerator and the denominator. So these two can cancel out. So what we're left with is y plus 2 over y plus 1. So now what we simply do is use this rule and just substitute back. So where all the y's are, now we just replace them back with x to the n, so that we can have our answer in terms of x, which is what we started with. So doing that, y, which is x to the n, will become x to the n plus 2 in the numerator, and then x to the n plus 1 in the denominator. And since there's nothing else to do, this is the simplified form for that rational expression.